then we're just going to calmly start.
Can we leap over?
No. On section 5.2. Now, here comes the factoring again. So, okay, well, we're going to do them all in depth. So, right. My number one thing on all of these, we have to continue to remind ourselves of this. The number one thing every single time is what we call the golden rule, which basically is there a GCF? Is there a greatest common factor? Something that all of my terms have in common that I can take out. 5. If there is, I need to do that before I do anything else, or attempt to do anything else. So once I take the 5 out, we're doing the distributive property backwards. So in other words, 5 times what would get me back to my first term? X squared, because 5 times x squared is 5x squared. 5 times what would get me to negative 20? Negative 4. Hence the next question. Is this one done? No. Now, I understand what you're saying when you're saying the square root both things, but, so does that just mean I write x minus 2 and I'm done?
Yeah.
Yes. And the reason that is we have a difference of squares. So those of you that said square rooted, I see what you're saying. What do I square to get x squared? That would be x. What do I square to get 4? Okay, that's 2. But then some of you that said, but I need plus and minus. Why is that? Because I need this to be negative. It doesn't matter the order that I have the plus minus in, but I do need to break it down again. It doesn't cancel out in a way that if I were to FOIL this out, I'd have x squared, and then as I'm FOILing it right, I'd have minus 2x and plus 2x. So the x term would cancel out, but the x squared and the 4 would still be there. So that's the type of thought process we're going through as we work these. What about number 2? 3. Okay. So if I take out a 3, what does that leave me with in the parentheses? Okay. So I take a 3 out of each of those. The 3 hasn't disappeared. It's still there. So now what? Okay. We've got to factor what's in there. Now some of you, when you see that number in front of p squared, that coefficient, you've been doing slide and divide. But here's what I would say on this one. Look at the numbers you're working with. 2 and 3. You don't have a bazillion options here like you do sometimes. So I really think we can handle this without going into slide and divide by just doing a guessing check. Because I know 2 times 1 is 2. I don't have any other options. I know both the signs are going to be positive. That's nice. So the only question is, I know 3 times 1 is 3. Where does 3 go? That's really all we got left to consider. So let's see. If I put the 3 here, 2 times 3 is 6, plus 1. Is 6 plus 1 get me a 5? No. So it looks like the 3 goes here. 2 times 1 is 2. 3 times 1 is 3. 2 plus 3 is 5. Okay. But again, could I slide and divide on that? Absolutely. Okay, I could slide the 2 down and factor it and then divide by 2. I'm just saying sometimes you might be able to save yourself a little bit of time. In common? 2a. So it can be a constant and a variable term. And I always got to get out as much as I can. So if I get out 2 but I forget the a, I'm not quite getting it right. So what's that going to leave me with? A plus 4. A times a is a squared. 2 times 4 is 8. That one's done. Okay, so sometimes it'll just be a greatest common factor, and that's all I can get out of there. What about that last one up top? 4. what's next? Factor it. Okay. So what multiplies to negative 1 and adds to positive 1? 1 and 1. Well, if I did 1 and 1, that would multiply to positive 1. What multiplies to negative 1 and adds to positive 1? What? Nothing. None. Occasionally, you'll get one that once you take out a greatest common factor, you're not going to be able to do anything else. Because here, if I did negative 1 and positive 1, which is what I'd have to do, that's 0. I wouldn't have an x term left. So I won't necessarily be able to do something every single time. So now, when I'm going through here, we're still going to be factoring, but now we've added a little piece. This little equals 0 part, which means now we're actually solving the quadratic. We're actually trying to find an answer. So when you do this, you need to set each set of parentheses or factor with x. I'll explain that as we go through. Equal to 0 and solve it. So when we go through something like 1, 2, 3, or 4, and we get all these x's or p's or whatever variable it happens to be, we're going to set each of those binomial, monomial terms equal to 0. Set. So here, this looks like one of our old favorites. Multiply to get the number on the end. Add to get the number in the middle. Okay? X plus 6 and x minus 3. So 6 times negative 3 is negative 18. 6 minus 3 is 3. So now all I'm going to do, some of you will start figuring out the shortcut for this, is I'm going to take each of those quantities, each of those sets of parentheses, and set them equal to 0. And whatever I get to those solutions, or what my answer is going to be. Because if I were to plug either of these values in for x, I'd get to the end and have 0. So if I plug in 3. 3 squared is 9, plus 3 times 3 is also 9. So 9 plus 9 is 18. 18 minus 18 is 0. I can just plug it in and they work. So are they always just going to be diamonds? Well, no, of course not. So like for instance here, the kicker here is this stuff, these need to be in equal 0 form. So these need to move their way over to the other side. So in this case, I'm going to subtract the 3r and add 5 because I want this side of my equation to equal 0. Okay, so we always need to start with equals 0. If it's not, we need to do whatever operations we need to make sure that happens to be the case. So now I got everything to the one side. Now what? Okay, I can take a 2 out. And in this case, that's kind of nice. Because now what's left is just a regular old diamond or a little bit of mental math here that we're going to do work on. I get my 2 out. Now I've got to factor what's inside. So again, we're looking to have two numbers that multiply to 25. What's that? Okay. Negative times negative is positive, and negative 5 and negative 5 is negative 10. When I go to set things equal to 0, this 2 that's sitting out here doesn't have a variable term with it, so we kind of ignore it. These are the ones that I'm going to pay attention to, but if I set r minus 5 equal to 0, I just end up with one answer, r equals 5. Okay, so if it's just a plain old rx, basically you can just change the sign like we did over here. X minus 3 was 3, r minus 5 is 5. I get my solutions that way. Let's see here. Okay, I can take a 2 out. I can't take a b because my last term doesn't have one. Now, here's one other suggestion I'm going to make. Yes. And the reason that you might want to take out the negative is, then your b squared term is still positive. That can get a little messy if it's negative. But be careful. What's my next term going to be? Nice. Negative b. Because I got to remember, negative times negative gets me back to the positive. So it's little detail things that can get you on this. So 2 that multiply to negative 30 and add to negative 1. Okay. Negative 6, positive 5. Negative 6 plus 5 is negative 1. Negative 6 times 5 is negative 30. Again, the negative 2 doesn't have a variable with it, so we kind of ignore it. Set each of these equal to 0. And basically, we're just doing some sign changes. So a lot of these will end up with 2 answers. Occasionally, you'll end up getting one that has only 1. So then, some of you, this is your all-time favorites coming up here. In some ways, yes. Okay, right. Similar to what we were doing up above in number 1, these are both perfect squares. So whatever I square to get each one, so if you're looking at it as square root, that's okay. So 2 times 2 gets me to 4. 5 times 5 gets me to 25. And again, since it's minus, I got to have one of each. Now when I set these equal to 0, I got to be a little more careful. Yeah, so I'm going to write these out. Subtract my 5 over the first one is 5. Add my 5 over in the second one. 5. But the whole key is here is being able to factor them. Now, one thing I am going to stress. Some of you are going to say, well, sometimes on one like 8, couldn't I add 25 and then just divide by 4 and square root and get the same answer? Yes, but there are going to be parts as we continue to move along in the course where you're going to have to be able to factor this to get to a solution. So I'm really going to press, you've got to use factoring right now to get there. So yeah, I'm going to be a little bit of a pain about that, but that's okay. Okay, oh, nice. Right, because now here, these are both perfect squares. Now I could go through and try to figure out what multiplies 124 and adds 24, and I get 12 and 12. But like just got mentioned, what was just mentioned, I can always just do it and say, oh, well that's like doing x plus 12 squared. What's the difference? None. I can write it either way. And then I just set it equal to 0, and I can only get one answer. But again, that's a way of doing a shortcut. If you notice it's a perfect square trinomial, if you notice they're perfect squares in the front and the back end, you can simplify. You can make it go faster. That's kind of what we're running here. Now I'll start throwing the twists in. Take out 8. What do I have left? That's minus 3. Now here's the first time. Our factor that we took out, our greatest common factor, has an x value with it. Whenever that happens, that also needs to be set equal to 0. But the only time that happens is when you have a variable term with it. Yes. Which makes sense because if I plug in 0 here, I get 0 minus 0, 0. Okay, that makes sense. So the only time, again, you're going to do that, not when it's just a number, a coefficient, but only when it has a variable term. And then since they're our favorites, let's hit up good old slide and divide here on the bottom, unless some of you go to mental math, which you may be able to. If you're going to go slide and divide, though, again, remember, it's that last term is going to get the 6 multiplied by it. So what multiplies to 12 but adds to negative 13? Negative 12 and negative 1. But again, this isn't just called the slide method, it's slide and divide. So that first number that I slid, I'm going to go ahead and divide in. Now, if it doesn't go in, that value slides back to the front, becomes part of my answer. But if it does go in even, 6 goes into 12 twice, I can get it factored that way. But then since it's equal to 0, I set each of those quantities equal to 0 to get my two solutions that way. I want to take a look at one more in this section once I give you a minute to kind of jot some of that down. We're going to take a look at 12, and then we're going to start doing a little blending. 12, again, for most of you probably will be classic heading back to slide and divide here. So one more time with this, slide that down. Okay. We know they're both going to be negative because it's a positive 45 and a negative number in the middle. 9 times 5 is 45 and adds up to 14. But again, don't forget, we're not just diamonding this, we did in the slide and divide. I just wanted to do this as a reminder for some of you. Just because it doesn't go in evenly means I just slide it back to the front and do 15x minus 5 and 15x minus 9. Here, 5 over 15, I can reduce the fraction. 9 over 15, I can reduce the fraction. And now that I've reduced it and I see that it doesn't go in, that's the point that I can slide that denominator back to the front and then set each of those equal to 0. So that factoring that we've been talking about and working with, we end up getting us our solutions on these, which would be 1/3 and 3/5. But again, it's all going to come back to, how are we doing as far as the factoring goes. So instead of killing you with all the rest of these, let's head to the back. There's just a couple other ones I want to peek at. I'm going to roll down here to 56 and 57. They find the dimensions of the figure. The area of a rectangle is 36 square feet, and they give us these variable values for the length and the width. How do you find the area of a rectangle? Length times width. Okay. So I have my length and my width. So my length times width equals the area. So I'm going to need to distribute this out. And I'm also, though, going to need to bring the 36 over, because I want this to equal 0, so I can actually solve it. So here's the actual expression that I'm working with once I have my information. So I'll go ahead with this and factor it. Let's see here. Multiply the negative 36 and add to negative 9. We know we're going to have one negative and one positive. It's a negative 36. We know the negative number is bigger. 12 and 3. So I set these each equal to 0. And then you sit there for a minute and you go, well, wait a minute. How can I have two answers that work? What might I not be thinking about here? One of these answers actually doesn't work. You're like, well, what do you mean it doesn't work? 12 minus 9 is 3, and that's 12, so 3 times 12 is 36. Negative 3 minus 9 is negative 12. Negative 12 times negative 3 is 36. What do you mean it doesn't work? What's that? Ah, I can't have a negative length of something. When's the last time you went to someone and said, yeah, that's negative 3 inches in length? You haven't, okay? That doesn't make sense. Even though mathematically they both work, common sense-wise, the negative number makes no sense. So we have to do it that way. So again, that's how those would work their way through. And then finally, finding the time in the seconds, I should say, it takes an object to hit the ground when it is dropped from a height of s feet. Use the falling object model, and they give you this equation. When something hits the ground, how high is it? 0, okay? So when something hits the ground, the h value is going to be 0. Now, if they told you something else, like there was a cushion there or something that was 5 feet high or something, you'd have to take that into consideration. But here our h is going to be 0. So when we're doing these, and we're using this equation, I'd have 0 equals 16t squared, because I'm looking for the time, plus whatever the initial height they're giving me is, which in this case is 64. So now I've got to solve this for t. Now again, this is just me. I like avoiding negatives. I'm going to add the 16t over here. If you chose to minus the 64, that would get you the same answer at the end. What would my next step be? Divide by 16. And now square root it. Now remember, when something's squared and I square root it, I get 2 answers. But let's think about this again. Which answer makes no sense? The negative. It can't be negative time unless we're doing like Back to the Future. So it would take 2 seconds. But that's how these work. There's applications to these things that sometimes we don't necessarily think about. So here's your task. Down here at the bottom. Okay, that's a variety of problems from just solving with those to a couple of the word type problems that are here. Like I always say, it might not necessarily need to be all of it right this minute, but you've got 15 minutes. It shouldn't be shut down. Because that's, again, when we get back into 5 days later, you don't remember how to do it. Yeah, so I beg of you, please start on this at least until like 20 till, okay? And that's about it.